Good day, fellow. Today we are going to do some applications of transversal waves. You see, let me give you this diagram. Suppose if we have a diagram like this, then I give you this point. Let's say this point is 4, then this one we say it's -4. Then from point, let's say from this point till this point, we have, let's say, 10 meters. Then I ask you, say we have A, B, C, D, E, and F. Then from A to F, we have 10 meters. Then I ask you this question now to say, calculate or determine the amplitude. How are you going to determine the amplitude of the given diagram? So simple. For amplitude 1, for amplitude, we always consider this formula, which is maximum minus minimum. 1/2 maximum minus minimum. Then which is going to be half. Our maximum point is 4. The greatest point is 4 minus. Don't forget to include that minus again, minus 4. Then we are going to get 8. 8, the half of 8 is 4. You see? Then for our amplitude, we get 4. Then now, number 2, let us determine the wavelength. How are you going to determine the wavelength? Firstly, you go to your diagram and try to figure out how many cycles do I have. Check from A, oh sorry, I forgot, from A till this point, we have a sine graph. We have the first oscillation like this. You see, from A till here, we have the first wavelength. Then we continue again by saying from this point till this point, we have another wavelength. Then how many are they? There are 2. Then you add them. 2 wavelength is equals to, no, this is not the final answer. Then you add them, 2 wavelength. Then you equate them to the total, which is 10 meters. Say 10 meters. Then at this point, we can then now do what? Divide throughout by 2. Then you get the wavelength, which is 5 meters. 3, let me ask you this question. Identify crest from that diagram. Crest, B, and D. Then for trough is going to be C and E. You see, it's so simple.